Hello everyone and welcome to the implementation of a graph overview lecture. So in this lecture we're going to implement just a simple graph by focusing on the node class. And you can refer to this lecture for the solution for the future interview problem where you're asked to implement a graph. Now keep in mind we've actually already implemented a graph earlier in this section of the course. So if you really understood that and you felt comfortable with it, you can go ahead and feel free to skip this lecture. But in this lecture we're just going to implement the code in this Jupyter notebook and explain it along the way, where we have a graph that's directed and the edges can hold weights, and we have three classes, a state class, a node class, and a graph class. And we build it this way just because sometimes in interviews they want you to fill out some code based off a node instead of an edge. So this is what we're going to build out. You'll notice it's going to look really similar to what we did previously, and we're going to take advantage of two built-in tools, the order dictionary and enum for enumerate, and they're basically going to allow us to, as far as the order dictionary, if we go ahead and zoom in here, there's links to the documentation at Jupyter Notebook for you. But the order dictionary, what it does, let's go ahead and look for it here. Order dict. So what an order dictionary does is basically allows you to run a dictionary, but it also remembers the orders that the keys were inserted in. So you can imagine that's a pretty useful tool for building out your graph. So it operates just like a dictionary, except that it also remembers the order that the keys were first inserted in. Okay, and the other thing we're going to be taking advantage of is enum, which is support for enumerations. And it's going to be a very basic class syntax. So we're going to say enumerations, just created using that class syntax, and it allows us to create really basic enumerations. And we're going to use that for this state class where we have unvisited, visited, and visiting 1, 2, 3. So we can call those instead of white, black, and gray like we did in the lectures. And you can see, you can read more on the documentation how you would actually grab this, but basically you just say print the representation of color red and it would give you out 1 for the enumeration. Okay, so let's go ahead and jump to implementing this. So the first thing we're going to have to do is begin by starting with that state class. So let's go ahead and say from enum imports enum. And you'll notice you may get an error where you have no module named enum. If you do have that, it means you're using Python 2 and you need to go ahead and install it. So if you need to install it, you can do that by running !pip install enum34, and if you've done a Anaconda installation, you should be able to run this. So then you just click Shift Enter and then wait for that finish to install. So I'm going to go ahead and let that install so we can use enumerate. If you're using Python 3, you don't have to worry about this step. This will work without the installation. So it looks like we've just finished installing it, so it looks all good. I'm going to go ahead and delete that. Before I do, I want to make something clear. I have an exclamation mark here so I can run this as basically a command line prompt. So you could also have put this into your command line or your terminal. So I'm going to put Shift Enter here. Let's run this again, and now you can see it works. Great. So that's going to allow us to create this really basic enumeration where I inherit from enum and then say unvisited is equal 1, visited is equal to 2, and visiting is equal to 3. Now it really depends on your interview situation whether or not something of this detail is necessary. You'll have to feel out and ask your interviewer if they really want that level of detail. But let's go ahead and then begin the node class. So we're going to initialize the node with self, and then it's also going to take in, we'll say num for num, and that's just going to be the number of that node. Some people also like to call this like the ID. So we'll say self num is equal to num. So, and then we'll say self dot visit state is equal to state dot unvisited. And that's really where we're making use of this. So it starts off unvisited, and now we can actually keep track whether it's been visited, it's visiting, or visited. So that's actually really useful. Again, it really depends on your interview situation whether they want you to take that into account, but you'll definitely gain extra points for thinking about it. And then we'll say self.adjacent as the adjacent nodes, and we'll set that equal to an ordered dictionary. Note, last time we were doing this, we just set this equal to a normal dictionary. Here we're going to take advantage of ordered dictionaries, which you may find useful for the BFS and DFS search algorithms. But in this case, for our ordered dictionary, we'll set the key is going to be the node, and we'll have that value be the weight of that vertex that connects it. And then one more thing I'm going to do is add a special method, underscore, underscore, str, underscore, underscore. So if I want to print the node, it returns something. And in this case, I'm just going to return self.num, basically the number of that node. Okay, so there's our node class, and now we just have to build out the graph. So I'm going to say class graph. I'm going to say initialize it. And I'm going to initialize it with just self. And we'll say self.nodes is equal to an ordered dictionary. And I should have pointed out earlier that we need to actually import this first before we run this. So let's make sure we actually say from collections import ordered dict. So make sure this all runs. So we have that. Let's continue on with the node. I'm going to make a method to add a node, which is basically adding a vertex, a node to this graph. And I will say node is equal to node num, so making a little temporary variable there. And then I'm setting self.nodes, that ordered dictionary, at that num equal to node. Then I'm just going to return node, that temporary variable there. So notice how I'm not saying self.node here. I call self.nodes here, so I can set that key, which is the node ID and the value. So then I can just add an edge by saying self source destination and weights. We'll set it equal to 0. So this should look extremely familiar. If it doesn't, make sure you review the first time we implemented an adjacency list. But it should look extremely familiar because last time we did this, we had from, to, and then weight was also at 0. And in this case, we'll say if source not in self.nodes, we will add that node. We'll add that source, and we'll say if the destination is not in self.nodes, meaning it's not in the graph, right? I will say self.add a node to destination. So we did this exact same thing earlier when we were doing the adjacency list, but basically what I'm saying is I'm going to add an edge, give it its source node, its destination node, and the weight of the connection between them of that edge. And what's going to happen is if the source isn't in there, I add it. If the destination is not in there, I add it. Once I've added them, I'm just going to say self.nodes source dot adjacent, and then this is where it gets a little tricky, but what I'm going to say is that dot adjacent method. So if we scroll back up, remember we have the dot adjacent, which is that ordered dictionary. So I call dot adjacent, and I also then want to call self.nodes destination on it and set that equal to the weight. Okay, and that should be it. So let's make sure it worked. So we'll call G as an instance of our graph, and then we can add an edge to it. So I'll go from 0 to 1 to 5. Notice that I didn't have to actually say add node because remember our add edge takes into account if the source and destination nodes aren't already in there. So we have that. And then we can actually say go ahead and, well, let's just say g.nodes, get all the nodes. And there we have our ordered dictionary with 0 and 1 nodes. And if we go ahead and say add another edge, if we wanted to, we could say g dot add edge. And we'll go, let's say, from 1 to 2 with a weight of 3. And that's fine too. If we look at our nodes now we have 0, 1, 2. Okay, so that's really all there is to it. Again, hopefully this felt a little familiar to you. Should have been some things that are really familiar, especially in those adding the edges, adding the nodes instead of the vertices, etc. So hopefully that all felt pretty familiar, but that's just another way to implement a graph in Python. And it's a super common interview question, and it is going to be one of your practice interview questions. So I really suggest that you review this lecture as well as the lecture where we implemented the adjacency list. All right. Thanks everyone, and I'll see you at the next lecture.